There we go. Can everybody hear me okay? Cool. So, yeah, my name's Stuart Smith. I'm pre-sales consultant for Flowmon. Some of you have probably seen me in there. Some of you have come over and had a chat with us. I've been doing pre-sales for, oh God, scary, 20 years now. Various NPM and APM and solutions like that. And I've been with Flowmon for just over 12 months now. And there's 4 key areas that Flowmon does. There's network performance monitoring, application performance monitoring, DDoS detection and mitigation, but also network behavioral analysis and what we call anomaly detection service. And we do that through a combination of packets and flows and various bits of other information that we take from networks. So that's the agenda that I want to go through today. Types of attacks, what we get sort of feedback-wise from our customers, what they sort of talk to us about, what type of cyber attacks that they're seeing across their networks, how we work with our customers to better sort of get them to use us as essentially an early warning system to say, look, you know, this is happening on your network, you might want to look at it. And we do that through, like I say, a combination of our own sort of what we call behavior patterns, but also machine learning, and anomaly detection, really all sort of automated baselines to say, this is what normally happens on your network. This user normally sends 50 emails today. Today they've sent 2,000 emails to a whole raft of different sort of email servers globally. Those are the types of things that we learn and look at, build baselines and trends around. So when we talk to customers, there we go. We find that one of the first things that they'll always say is, well, not always, but they might say, oh, well, we've got, is this working? Yeah. We've got a firewall, we've got antivirus, we've got IDS. My network gurus will always find out if there's any dodgy stuff that's happening on my network. I don't think we need any sort of network behavioral analytics. Am I pointing this in the right direction? Oh, it's great, going backwards and forwards all over the shop. You can stand there and just...
Tap me on the shoulder.
And then they come back to us and say, well, I don't think we need any network behavioral analytics because we're pretty much covered by what we've already got. But then we find out, we'll put in our solution, we'll do a POC, as you know, all of these types of companies do. Most of the time we'll be doing a POC for network behavior monitoring or application performance monitoring. And as we're doing it, we'll say, well, do you want to have a look at anomaly detection anyway? You know, we'll put the software in for X amount of time. And I'm working on a POC with a county council at the moment. They're looking at around 60 or 70 schools, so that's probably about 20,000 students that they're looking at. So we put the system in, we put in just a license on our box, and within 10 minutes we'd already discovered a load of peer-to-peer traffic, you know, BitTorrent, file transfers, file sharing, all this type of stuff that they assumed because they'd got various blocks on their firewall that they were going to stop seeing that type of traffic. So we just created, you know, just said, look, you know, these students are doing this, this and this. And the way that we do it is we're not looking at just TCP ports, we're looking at the way that students are using that particular application. So we'll say, right, okay, well, this user is trying to connect to 200 servers globally, downloading lots of small bits of information. That's how BitTorrent and, say, peer-to-peer trafficking, you know, sort of applications work. So we're not just saying, oh, block this, you know, these ports or look at these TCP ports. We're saying, this activity, this user is doing X, Y, and Z. You might want to look at it. Another example was a user will connect to a server and transfer, say, 20 gigs worth of files. They'll then connect to the internet. They'll then connect to Dropbox, and they will then upload 2 gigs worth of data. So we put those heuristically together and say, I've seen this user do this, 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 and this. You might want to look at it. And that's where we're learning about this adaptive baseline that we look at, And the way that we build this model to say this is normal activity, this is out of the ordinary, you might want to look at it. And these are obviously some of the things that our customers are talking about. Cryptojacking, crypto mining, whatever you want to call it, is something that everybody's heard of. And we had a customer the other day that there's always this assumption that someone's going to do crypto mining by coming into your network from the outside. So they will find a way in, and then they will start hijacking your CPU and memory on your systems, building up continuing that crypto mining, getting a direct internet connection from that server outwards so they can then start getting all that money and using all that resource. We had a customer that it was a person on their own network who was doing crypto mining whilst they were sat at their own desk at work. They had installed the software, they'd hijacked a load of the virtual machines, they'd created and built and installed their own proxy server. So as far as they were concerned, they were invisible. After a few days, the customer found out, saw a load of spiked CPUs, thought, what's this? Drilled down a bit. 3 or 4 days later, they found out. The way that we'd have learnt it straight away is we would have seen this random proxy server appear on the network. So we'd have said, this box isn't in your list of proxy servers. Why have you put it on there? You might want to look at it. VPN filter as well, especially for Internet of Things that everybody talks about, but also SCADA devices, utility plants, power stations, oil works, all these types of areas that sometimes get forgotten. There was a SCADA attack of that VPN filter, a Ukrainian chemical plant, and that was in July 2018. That happened. And it's because a lot of these SCADA devices are obviously now IP-based. For some reason, they have connections to the internet. Whether they need connections to the internet, that's another question. But obviously, then our system will look at what was normal activity within that SCADA environment and say, well, this is what all these boxes were doing yesterday. These boxes are now doing this, this, and this. A lot of those SCADA devices will just have the bog standard username and passwords that have been used out the box. So it doesn't really take a rocket science to even get onto these boxes to start doing things. And that VPN filter, malware, hack, whatever you want to call it, could also disable boxes, stop them connecting to the internet. So it was a particularly nasty thing. Ransomware as well is obviously something that a lot of people talk about. I mean, my 76-year-old mother has heard of ransomware. That's how, it's a daily occurrence. And a lot of the enterprises and customers that we talk to are starting to make assumptions that they're not putting our software in to alert on when there's a likely attack. They're making an assumption now that they've either been attacked, they're in the process of being attacked, and they just need to know where's it coming from, and what can I do to start pinpointing where, is it an internal attack, is it external, DNS hijacking as well. All these things you hear about on the TV, you hear about on the news, they are there, and they're just going to get more prolific, they're going to get more advanced. I mean, things like DNS hijacking, the principle's quite simple, make a DNS request to go to a website, the website that comes back is a hacked website, and it installs malware and God knows what else on your system. That then internally obviously then spreads, and it's this whole vicious circle. So, like I said, a lot of the 74% of cyber attacks are sort of internal, because we're finding, obviously things like GDPR, there's this whole sort of knee-jerk panic reaction that everybody needed to know about what was happening with their files, who was downloading files, who was downloading onto their laptop, all this type of information. Everybody should have really been doing that beforehand anyway. Everybody should have been able to at least have the technology in place to monitor and say, these users are connecting to this, these users are doing this, they're downloading this, etc., etc., etc. So because of the way that anomaly detection or network behavioral analytics works, this F here, you see what my colleague's done, very clever with the FLOW, Flowmon, very clever. You can see, look for the red flags, look for stuff that just is different on your network, and that's what anomaly detection does. It's not based on signatures like you get with antivirus, where you have to wait for a signature update. A lot of these will be zero-day attacks that will get flagged up. We won't say it's malware. We won't say it's this infection, it's this, this, and this. It is just saying this is out of the ordinary. It's not normal. You want to look at it. Helping your staff learn. I mean, this, you know, teaching people about phishing scams and all that type of stuff is brilliant. An example of here today, you know, I've got my presentation on my laptop. I transferred it onto that laptop there by a USB key that somebody gave to me. I just took that USB, stuck it into my laptop, copied it across, gave it to somebody else, they put it on. You know, I didn't, you know, I should have checked it and has this been scammed? Has it been this? Has it been blah, blah, blah? A lot of the laptops that are sat around here, people haven't locked their screens. You know, it's all basic stuff that we're all told day in, day out. But these things, you know, you really do need to sort of talk to staff and really get them to understand the impact of opening up a dodgy email. It's not just a fact of, oh, I might get, my antivirus will stop that happening. It's far more advanced than that. And it's having technologies in place to do that alerting, to integrate with each other. You know, a lot of places will have a SIEM solution. You know, so you'll have a single pane of glass. You'll have a dashboard that shows all the events that's happening on your network. You want all these different systems to integrate. You know, so you want your firewall information, you want your antivirus, you want to make sure that everything's been updated. You want your anomalies to be flagged up and centralized into the SOC, you know, your security operations center. And that's where, you know, we're saying that they all integrate together. You need to be able to link all these. Ours isn't, you know, the be-all and end-all solution. It's just a part of a much bigger security environment that you have within your estate. And the way that, you know, networks are, these hybrid networks that you have, you've got some on-prem, you've got some in the cloud, you've got some virtual servers, you've got some physical kit. There's all these different bits of information and different areas that have started to spread across people's networks. You know, so there is a visibility gap, you know. This team's looking at the servers, this team's looking at this team's looking at this, etc., etc. You want to be able to say, well, actually, when we find an anomaly on the network, when we find some sort of behavioral spike or dip or traffic anomaly or whatever it is, you need to be able to say, well, is it coming from here? Is it across here? And those are the types of information that you will get from this machine learning, this sort of adaptive baselining that says, again, like I sort of keep harping on about, but it's this isn't normal, you want to take a look at it. And also then looking at, you know, sort of end user behavior and all these sort of security gaps that you sort of see. So Flowmon, you know, as a company, I don't know how many of you have heard of Flowmon. So our head office is in the Czech Republic. It's our technology, it's our research and design guys. So, like I say, we use flow data. So, from a deployment perspective, you've already got the technology in place for us to be able to do what we do. So, your switches, your routers, your firewalls, your IDS will all be sending out flow data. So, we can take that flow data, and then that's where we do our analysis. You know, so it's not a huge deployment exercise. It's very simple and straightforward. As long as you can get us the information for us to be able to look at it, we will do the analysis and say, this has happened, you might want to look at this. You know, things like SSH dictionary attacks. The way that we do that is the way that we see a lot of log on fail, log on fail, log on fail to lots of different systems across your estate, and then we will say, right, okay, this looks like somebody is trying to do X, Y, and Z. And that's the way that we do it, the way that technology, so, you know, so we don't really necessarily need to go down into deep packet inspection level. We can do it from quite a high level. Come on, Stuart, you can do it. Oh, for heaven's sake. You're going to get sick of seeing this one going backwards and forwards. Anyway, that slide that won't, there we go. So, yeah, so you've got, you know, your network analysis tool. Ours sits in here from a network, from an application, from SIEM integration perspective. And now my final slide, wow. That's, you know, RESTful APIs, all those types of things that you'd expect to be able to see from the way that our technology integrates with everything that you've got. So, there we go. Oh, fuck. That's me anyway. Remember, he's the bloke who can't use one of these. So, thank you very much.